First of all, we will start with the properties of wave. Wavelength, or lambda, is a distance of wave traveled during one cycle. The unit is in nanometer, picometer, or Armstrong. Frequency, V, is the number of cycles when wave undergoes per second. The unit is in. Amplitude is the vertical distance from middle line of a wave from crest to throat. And then we have electromagnetic radiation. Electromagnetic radiation is the emission and transmission of energy in the form of electromagnetic wave. The formula given, C equal to V lambda. What you see here is the region of electromagnetic spectrum. As you can see, we have wavelength and frequency. The higher the wavelength of a wave, the lower the frequency. Wavelength and frequency are inversely proportional. The higher the frequency of a wave, the lower the wavelength. Invisible light can be seen with naked eyes. Example, gamma rays, X-ray, ultraviolet, infrared, and microwave. Visible light is a light that can be seen with naked eyes. When a white light passes through a prism, as you can see on the picture, it creates a variety of spectrum of light, like red, orange, yellow, green, blue, indigo, and violet. Planck's quantum theory. Based on quantum theory, the energy in the form of electromagnetic radiation can be emitted or absorbed in discrete amount. As you can see here, the nucleus is emitting and absorbing photon energy. Then we have line spectrum of hydrogen atom. If an electric discharge is passed through a gas discharge tube containing hydrogen, the high energy electron from negative electrode to positive electrode collide with the H2 molecule. This causes H2 molecule to dissociate into H atom, and the tube emit light. When the emitted light is passed through a prism, the light is dispersed and separated into its components. Bohr model of atom. Electron can only have specific quantities of energy values. The light is emitted as electrons move from higher energy level to lower energy level.
Assalamualaikum and hi, my name is Muhammad Rafiq Firdaus bin Al-Junaidi. Today I want to present Chapter 2, CHM131, the subtopic of Chapter 2, Periodic Trends of Elements. As we know, in periodic table, we have group and period. So for group 1, we know as alkali metal. Group 2 we know as alkali earth metal. Group 17 we know as halogen, and group 18 we know as noble gas. So first, we go for atomic and ionic radii. There are two major factors affecting the size of atoms. First, the effective nuclear charge ZeV value, the residual net charge felt by the valence electrons. Second, the shielding effect, also known as screening effect, caused by mutual repulsion of electrons for each other. For ionization energy, across a period, the atomic size decreases from left to right predictable. The ionization energy increases across a period. But down within a group, the ionization energy decreases and atomic radius is increased. For an ion, when atom gains electron and larger than neutral atom, it is because electrons are added into the same shell and tend to repel each other and so increase size. The meaning of electronegativity. So, what can we define electronegativity? Electronegativity is the ability of an atom to attract electrons or electrons density towards itself in a covalent bond. Across a period, electronegativity will be increased because more protons, more power for the element. Down to the group, electronegativity decreases. It is because the atomic number increase down a group and thus there is an increased distance between the valence electrons and nucleus or a greater atomic radius. Now we go for size of atoms. Across a period, from left to right, size of atom is decreased. Why? It is because the proton number leads to increase in ZeV. The valence electrons got the greater attraction pulled closer to the nucleus. Down within the group, size of atom is increased. So now we go for size of ion. As we know, there are two types of ions, such as we have cation, such as positive ion, and we have anion, negative ion. The size of positive ion, when atoms lose electron, and for sure smaller than neutral atom. Why? The atom lost valence electrons, leaving electrons of the inner shells which tend to attract the more nucleus, thus decreasing size. By following the periodic table, across the period, ZeV increase from left to right periodic tables, and down to period, ZeV is decreased. Now, we go for electron affinity. What is electron affinity? Electron affinity can be defined as the negative of the energy change that occurs when an electron is accepted by an atom in the gaseous state to form an anion. The more negative the electron affinity, the greater the tendency of the atom to accept an electron. Electron affinity is increased when across a period and decreased when down to group. Electron affinity follows the trend of electronegativity.
Hello, my name is Danish and I want to do the presentation of hydrogen emission spectrum and Bose theory. What is hydrogen emission spectrum? The hydrogen emission spectrum is the pattern of color or wavelength of light product when excited hydrogen atom release energy. How it happen? Hydrogen atom absorb energy. This energy can come from heat, electricity and radiation. The electron cannot stay excited. It quickly falls back to the lower energy level. When it falls, it releases energy as light pattern, and the amount of energy released determines the color wavelength of the light. If you look at the picture, there was a pattern color of hydrogen emission spectrum. The red line is H alpha, translation N3 to N2. Blue and green line H beta transition N4 to N2. Blue line H gamma transition from N5 to N2, and violet line H delta transition N6 to N2. If you ask why the color shift from red go to violet, it is because the low energy is longer wavelength, and that's why you will get red. While medium energy, you will get green and blue. While high energy can make short wavelength, and you will get violet. If you ask me why is hydrogen emission spectrum important, the reason is it proves that electron exist in fixed energy level, and it helped scientists to identify hydrogen in stars, and it was strong evidence that energy is equalized. Now I will explain to you guys about Bohr theory. Niels Bohr developed his atom model in 1913 to resolve the failure of classical physics in explaining the decreased line spectrum of hydrogen. According to classical electrodynamics, an accelerating electron should continuously radiate energy and spiral into the nucleus. Bohr avoided this paradox by introducing the quantized electron orbit. Fundamental postulates: quantization of angular momentum. Bohr postulates that an electron can occupy only those circular orbits from which its angular momentum is equalized. There was a formula that mvr equals 2 pi nh. Second, stationary state. Each allowed orbit corresponds to stationary state with defined energy. While in this state, electrons do not emit electromagnetic radiation despite undergoing centripetal acceleration. Third, quantized energy level. From the balance of electrostatic attraction and centripetal force, Bohr derived the energy of each orbit. The negative sign indicates the bond state. As increase, energy level become closer together, approaching zero at ionization. Limitation of Bohr theory. Although revolutionary, Bohr model is incomplete. First, valid only for one electron system. Second, cannot explain fine structure, Zeeman effect, or Stark effect. Third, assume defined electron orbit, violating the uncertainty principle. And the last one is neglect wave nature of electron. This limitation led to the development of wave mechanics and quantum orbit. For the conclusion, Bohr theory introduced quantization, stationary states, and energy level transition, successfully explaining the discrete hydrogen emission spectrum and laying the foundation of modern quantum mechanics, despite its classical assumption and limit accessibility. That's all from me. Thank you, and sorry for many mistakes, and good luck.